Everyone. In this video, I'm going to go through how I almost successfully solved the IBM August problem, and then how I just about failed to do so. So the first thing I started off with when I saw the puzzle is I basically thought I could do it computationally. So I basically rewrote the um, what's called the Monte cake cutting problem, which is basically what the entire problem is, and did it within code. So I'm not going to go through the whole thing. Basically, it's just basically how the cake cutting game works. And then the main thing, which in hindsight was very obvious, but at the time wasn't, was what the best strategy was. So I set like different settings for whether you wanted to divide each box into the largest or the smallest, by the largest or the smallest prime factors, things like that. Or whether you wanted to minimize or maximize what their side looked like whenever you were making a cut. So I set up all these settings just to figure out, okay, what works. Then of course, for the idea of someone getting like extra turns at the start, or basically getting free blocks or free cuts, I basically treated that like at the start you kind of had a solo box game where one person was just making little cuts to their own little 1x2s or 2x2s, or 1x2s or 2x1s, and then the other person was actually cutting the box. So it's basically like a solo box game. So that's how I set it up. And then that would lead into like an actual box game. And then, of course, with different people starting. And so I just did a bunch of computations about what worked and what the best strategy is. And after a very long time of just doing that, of basically testing, I thought, okay, there's no way that doing this numerically is the best idea. I just didn't think it was, so I kind of started searching for similar games like this or more kind of game theory like questions. And then eventually, after just literally just Google searching for ages, I found the name of the game, which is literally just the Monte K-Cut game. And I actually found the book that they directly reference in their solution. So eventually, got to the book, got to the point where they talk about this, and basically once you get here, you basically have the solution. They just tell you the easiest way to get there. So going down to the correct page, where is it? So going down to the correct page, it just tells you the rule. So basically how I kind of solved it was I literally just found the book that they were referring to. See here, this example is 99,000. And the rule is that you find out how many extra turns the one of the people needs for it to be like a completely fair game. You just solely divide by its prime factors, then the one with the most prime factors wins, and then by taking this number and adding them together, you get the solution. So I thought, okay, I basically have the solution. So then what I did super simply is I got the prime factors of each of the numbers, but the one problem is that I'm incapable of counting properly. I'm not incapable, but I just didn't. And so I thought that if you go through the steps where you cancel out basically the largest prime factors here with the largest prime factors here, that you get left with two prime factors, this one, this one. However, It's actually incorrect. If you actually do it out properly and you cancel out all the prime factors properly between these two, you're only left with this. And I was left with this because I got it, because I missed it, basically there. And so that's all right. And that's how I failed to solve the August IBM problem. Just a lesson to everyone to remember to count properly and to pay attention. Thanks for watching.